So today we will study Laplace transform and its application analysis. I think you have learned Laplace transform in Math 197 course, but in this course we'll see many applications of Laplace transform in circuit analysis. Actually, the Laplace transform is a method which is done in the frequency domain, because earlier we have learned the time domain analysis for circuit analysis, like doing the that was the time domain analysis. So now we are going to study the circuit in frequency domain analysis. So in frequency domain, Fourier series also a frequency domain analysis, but in Laplace transform, little bit different from Fourier transform. Although Laplace transform comes from Fourier transform. Basic form of Laplace transform is actually Fourier transform. However, in Laplace transform, we can see little different, which has the x-axis, that is the this one. Only the difference in Laplace domain. The main objective of Laplace transform is to show the circuit analysis in frequency domain, and another objective is know how to model a circuit in Laplace domain. And from that Laplace domain, you can apply the same matrix in MATLAB software. So Laplace transform learning is an important for electrical and electronic engineers. So that we'll focus as much as we can see the Laplace transform application in circuit analysis. So before going to circuit analysis, we will basic formula transformation also, because in Math 197 you may have done only the development, but in this course we'll see some formula development plus theorems as well as their applications. This is the target of this topic, and at the end we will see some modeling system. So Laplace transform was developed by Pierre-Simon Laplace, who is a French mathematician. Name the Laplace transform has been named.
Suza, turn off your microphone.
So on this slide, we can see the effectiveness of Laplace transform and its formula. In Laplace transform, we have two formulas. One is called bilateral, unilateral transform. In case of bilateral transform, In case of bilateral transform, the limit has been taken from left side to right side. That means both sides. Because of both side limit, it is called the bilateral Laplace transform. Bilateral transform. You can see the limit minus infinity to plus infinity. And unilateral 0 to infinity. 0 to infinity. Okay. So that's why it is called unilateral. So f of t usually is the function in time domain. If we convert this time domain function into frequency domain or Laplace domain, then it is called capital F of s or capital L of f of t. Both can be used for express the Fourier series, Laplace transform. Okay, S is the indicator of Laplace transform. S is the indicator of Laplace transform, and Fourier transform is j omega or omega. Simple. That is the Fourier transform indicator. But in Laplace domain, the S is the indicator that whenever you see f of s, that means this is in Laplace domain equation or formula. That formula is minus 0 minus 2 infinity f of t e to the power minus st dt. Okay. So here is the difference is e to the power minus st. And that is equals to, we consider that sigma plus j omega. Sigma plus j omega. Okay. That sigma as
Sir, এখানে 0 how, sir?
Okay, I will explain that one. So S equals to sigma plus j omega. So this sigma and j omega axis you have seen in the last slide. That is, one is the x-axis, another one is y-axis. That means it is a complex frequency domain. Okay. However, the question arises, why it's 0 minus? The reason behind it, the 0 is our origin, right? Then how 0 minus we are thinking? Here I am showing in the right side, you can see the coordination quadrant, 4 quadrant. Here is 0. Okay. Now in real case actually what happened, if you consider a capacitor charging and discharging, then capacitor always store a stray charge. Do you know? You have learned in the motor stray loss.
Yes, sir. Yes, sir.
That kind of some residual charge or residual magnetism always in the substance. Okay, so whenever you use that substance for some application, then you have to think its previous state also. It means in electrical engineering is the previous cycle. Okay, so if we want to start our analysis from 0, then the previous, what was the previous state? We considered it is start from negative side, right? That's why it is 0 minus. We considered that we considering from previous time. That's why it is 0 minus. If you write down 0 plus, it does not mean. Still its value is 0. Okay. Due to the value 0, we 0 minus, just minus shows that I am carrying from the last cycle.
In unilateral, sir, unilateral Laplace transform, there is minus 0.
Yes. Minus 0 or 0 minus, it does not matter at all, because
It was
minus
same.
front or behind. Front or behind. That's all.
Okay, sir.
Do you get the question answer? Because it is critical questions for us, because it is based on the properties of the material, like the magnetism or the charged materials, dielectric materials. Those are having this kind of property that we must consider the previous state. That's why 0 minus we consider. Clear, right?
Yes, sir. Clear, sir.
Here in the slide you can see some formulas of Laplace transform. So those formulas you already have learned from Math 197. So you must remember those formulas. These formulas you must remember. The delta function, its Laplace transform is 1, and u of t, that means the unit step function, that Laplace transform 1 over s, and t is another type of signal, that Laplace transform is 1 over s square. Okay, 1 over s square. This is the thing actually. How it's coming, everybody knows. Have you proved in Math 197 this formulas? Because if I show you Laplace transform is 0 minus to infinity, right? F of t e to the power minus st dt. This is the formula, right, of Laplace transform. So if you want to consider whatever, like number 2, if you want to consider number 2, just write down here 0 minus t u of t, and u of t means 1, right? What does it mean, u of t?
Yes, sir.
1,
1,
because
sir.
it's unit step function.
Yes.
So this is the formula. From there, just do integration. So from here, integration, what is integration? Minus 1 over s e to the power minus s t 0 minus to infinity, right? 0 minus to infinity. So if you put this limit, then what is coming? 1 over s power minus s infinity, minus minus plus, then it is coming e to the power of 1 over s e to the power minus s into 0. That means the e to the power infinity is 0 plus 1 over s, and e to the power 0 is 1. Then The result coming 1 over s. This is the proof of this. Similarly, you can do every function. These all are f of t. You can see it is written f of t. If you want to convert in f of s, then you have to follow this procedure. Okay? Procedure to find out this f of s.
So 4 students are waiting to join the class.
Oh my God, then big problem. T becomes f of s.
Yes, sir. Clear.
So you can practice yourself, others. Now we will see Laplace transform of derivative function. Laplace transform derivative function. This is a kind of important. What is the derivative functions in terms of Laplace transform, right? Because there are so many applications of derivative functions in electrical system. So that you must learn this one as well as the later one very carefully. So what it says, the derivative function should be Laplace transformed. So the function is d by dt f of t. This should be converted, not f of t. So d by dt f of t should be converted in Laplace domain. So if you want to convert, then f of t, basically this d by dt f of t. This function itself is the single function. Okay, so that we convert it into 0 minus to infinity e to the power minus st d by dt f of t dt. Just replace the position because we have to consider the uv. Which one is u, which one is v, we have to consider. That's why we converted into this term. So if we apply
Only sir UV formula, sir.
yes, we have to apply uv formula. So the e to the power minus st, we consider the u. Okay, we consider the u. And d by dt f of t, we consider v. This is v and this is u. So if we apply, then u integration 0 minus to infinity d by dt v, right, u v, then d by dt u and integration of v dt and overall dt. Okay, this is the formula. So we have applied here. So that we have found that integration d by dt f of t becomes only f of t, because derivation and integration cancel out each other. This part. Second part, look at 0 minus to infinity. First one is derivative. Derivative minus s into e to the power minus st. And this one becomes f of t dt, because this integration and differentiation cancel out each other. So it becomes f of t dt. And after that, putting the infinity limit, then it becomes e to the power minus s infinity. So e to the power minus infinity always 0. So we will have only when we get the 0 minus. So e to the power minus st and 0 minus if you put here, then it becomes value 1. So overall becomes minus f of 0 minus. In second term, minus minus becomes plus, this plus sign. Then s take it out from the integration, and 0 minus to infinity f of t to the power minus st dt. What is this? This is f of s, isn't it? Look at the previous slide. Second slide.
Hello, sir.